Vetrii Engineering Academy. In this lecture, we are going to see slope deflection equation, which is very important topic in structural analysis. Okay, and you can expect some questions for the competitive exam from this topic. So let's see what is slope deflection equation, how it is generated. Okay. So first is what is slope deflection method. So slope deflection method அப்படினா அதுல பேர் சொல்ற மாதிரி slope deflection சேர்ந்து you are going to write an equation, and from that equation you are going to do the analysis. Analysis you are finding out the unknowns. இப்போ உங்களுக்கு unknowns கண்டுபிடிக்கணும், like what is the deflection, இல்ல what is the slope, what is the moment, shear force எவ்வளோ. ஸோ இதெல்லாம் கண்டுபிடிக்கணும் அப்படின்னா you should be knowing what are the details, correct? So அந்த மாதிரி details கண்டுபிடிக்கணும். Okay, you want a value. For that you are writing an equation mainly for statically indeterminate structure. So statically determinate அப்படின்னா you can find the unknowns with the help of three equations of equilibrium. Ana inga in case of statically indeterminate you require some additional equations. Okay, that you call it as compactability equation illa equilibrium equation, where or additional equation ungalku kedacha ungaloda unknowns ellame kandupidichidalam. Okay, so here this method, slope deflection method, is falling under displacement method. There is a broad classification on the different types of methods for doing the analysis. One is force method, another is displacement method. So in force method you are keeping the unknowns as forces. If the displacement vanditingna, that is you are keeping the unknowns as displacement. Displacement is where the change in the dimension, okay, delta v, delta h, illana the change in angle, so that is slope. So both slope and deflection are kept as unknown here, and this is falling under displacement method, and the other names are stiffness method. Okay, it's all coming under the category displacement method. And also when you see the equilibrium conditions, when I saw a compactability equation, you know, equilibrium condition I can solve the unknowns in case of statically indeterminate structure. So inga why, if using this displacement method you are going to use equilibrium equation. So first you equilibrium equation then you are solving it's an equation unknowns can be found out. For that you require some assumptions. So what are the assumptions அப்படினு பாத்தீங்கன்னா, first assumption is the plane remain constant. The plane remain constant meaning is first before bending and after bending, or before loading and after loading it remains same. So the angle between them is same. So that's the first assumption. Second one is you are totally eliminating torsion. So torsion it is a twisting bending moment. So bending moment and a force at a distance. ஒரு பாயிண்ட்ல இருந்து எடுத்தா அங்க இருந்து perpendicular distance into that force gives you the moment. அதே moment with the twist, then you call it as torsion. So that torsion you are eliminating. And the third one is shear deformation. So shear நால வரக்கூடியது. What is shear? Surface-ல இருக்கக்கூடிய deformation. So it in the surface, just shearing off at the surface of a element. So that shear, and the shear you are eliminating. So that's the third assumption. Yeah. So with these assumptions and also some sign convention, you are going to write the equation. An equation, equilibrium equation. Adi எழுதிட்டு you are finding the unknowns. So what are the sign convention? அப்படினு பாத்தீங்கன்னா, first one moment, rotation and settlement. So rotation and moment ரெண்டுமே என்ன எப்படி பார்க்கலாம்? ரொட்டேஷன்ங்கிறது it is something related with angular change. அதே மாதிரி தான் moment it is load at a distance. So that is also causing a rotation. Okay, so both rotation and moment ரெண்டுத்துக்குமே you have the same sign convention, that is the clockwise moment you are taking it as positive, anti-clockwise negative. So rotation adhe mari clockwise rotation nadakudhu. Okay, when it is getting deflected you can see a rotation happening. So that if it is happening in clockwise direction then you consider it as positive, anti-clockwise varumbodhu negative. Now when you are seeing into the settlement, so settlement na it is sinking of support nu sollaam. Adhavudhu a b rendume ore level la irukku, rendu support irukku, edavudhu onnu sink agudhu illa down agudhu due to the differential settlement. Okay, soil settle agudhu due to some reason, illa loading indha pakkam romba high ah irukku, it is settling down. So illa rendume settle agudhu, endha case vanal irukkalam. So rendume settle ana piragu after the settlement finally what is a elevation difference, level difference between them will give you as delta. So suppose if left side is settling more, compared to the right end you consider positive, and the opposite, right side sinks more compared to the left side, you consider it as negative. So that's a sign convention you are using in equilibrium equation. Okay, so now first நமக்கு என்ன தெரியணும் அப்படினா இதோட எப்படி ஒரு slope deflection equation get right. So slope deflection equation எழுதணும்னா I have to consider these 4 cases. So in the 4 case which each case will give you one term in that equation. So அவங்க question கேட்கலாம் how many terms are there in a slope deflection equation? Totally 4 terms. So எது பேஸ் பண்ணி அந்த 4 terms வந்துடுச்சு. Okay, so this is the reason. First one, moment due to the rotation at A alone. Suppose you are having a component or a member like A and B. Okay, suppose you are having a component A and B, then in that we can see here one end is fixed, another end is fixed. Okay, suppose you are taking an example. So in that case, first case is I am taking rotation at A alone. So this is A and this is B. So I am taking only theta A is happening. Appadina, what is the moment coming at B and A? I have to note it. That's the first step. Second one, moment due to rotation at B alone. Second case la I am taking only theta B. Theta value is only coming. Only rotation is happening at B end. Third one is the fixed end support. You are assuming that both the ends are fixed. Actually நம்ம questionல சில டைம் hinge-ஆ இருக்கலாம், roller-ஆ இருக்கலாம். ஆனா when you are using slope deflection equation, you have to assume that both the ends are fixed, then you have to write fixed end moments. So there are a set of formulas for different loading cases. So அதுக்கு ஏத்த மாதிரி you can learn. Okay, so I will be displaying that. Then this A and B இதில் இருக்கிற ஒவ்வொரு டேர்மும் ஆட் பண்ணி you will get slope deflection equation. Okay, and the last one is moment due to the settlement of B alone. You are taking the case that this is the case you are taking, and that is B is below A. So AB அப்படின்னு சொன்ன இந்த equation formationல you are considering the case that right end is sinking, then you have to take it as negative sign convention. What is the moment? What's the last term due to the sinking? அப்படினு கேட்டா it is 6EI delta by L square, which is negative. You're considering it as negative sign. Why you're considering negative? Because the sign convention is negative. Right end is sinking. So in the question கேட்கலாம் only sinking of support நால மட்டும் இருக்கிற moment எவ்வளோ of that term alone. So that is 6EI delta by L square. So comparing all this or adding all this, if you add, you will get final slope deflection equation. Okay, so formation of slope deflection equation itself is important. Adula no question vandirukku. Okay, then next see what is it looking like. First I am writing slope deflection equation for the end A. Suppose AB அப்படினு இருந்ததா A end la ஒரு equation, B end la ஒரு equation. So totally for a span, suppose I am taking for a span, then it is 2. So for a span it is 2. So totally you are getting 2, correct? So only 2 equations you can write. Slope deflection equation, SD means slope deflection equation you can write for a single span. So ஒரு span-க்கு 2 equation. Okay, even that can be asked. எத்தனை span இருக்கு? Suppose 3 spans are there. How many equations can I write? This slope deflection equation will be for one span it is 2. So totally for 3 span it will be 6. So and the questions also you can expect. Then the settlement, what is the sign convention taken? Settlement is negative. You are taking the right end is sinking more than the left end. Okay, so and the this is the final equation. I can write 2 equations, one at the end A, another at the end B. Okay, so now this I can take, so I'll tell you this is at the end B. Okay, now what I am going to do is here in the MAB and MBA, these are 2 ends, MAB and MBA. So 2 equation I can write containing of 4 terms. Ida munadi paatha 4 term, 1, 2 and 3 and 4. Okay, so each term is because of one slope or rotation at A alone, and another one rotation at B alone, another is sinking of support, and another is the fixed end moments. So in the 4 terms சேர்த்து I am writing the slope deflection equation. So in which I can take common. So common 2EI by L I can take. So it is twice of A. The twice of A இதனால வருது because I am taking for the end A. A ல இருந்து எடுத்தா it is twice of A and 1 times of the angle, the slope theta B, and this 3 times 3 delta by L. Why 3? Because I am taking 2 outside. 6 EI delta by L square. அதுதான் என்னோட rotation moment due to the sinking. Correct? So if I am taking 2 EI by L common, I can get the formula as 2 theta A plus theta B minus 3 delta by L and fixed in moments at FAB. So from A to B. So it is a left hand side la irukra fixed end moments irukano. So you have direct set of formulas for different type of loadings. Directly you can write. Now when you are taking or going to the end B irunda, the B end ku pogumbodhu again you can write the same way. Adhe 4 terms but you are trying to write it for the end B, right hand side end la. So adhe mari you can take the common term outside. Here what's the difference? Here it is theta A. So A end paakumbodhu A is only once. So I am writing for BA, from B, the end B. So B la irukra angular will be twice. So inga A la irukumbodhu 2 theta A. Here it will be 2 theta B and rest all is same. Again when you are writing the fixed end moment வந்து right end la irukkiradhu எழுதணும். Okay, so you have ready made set of formulas for fixed end moment. Okay, மத்தபடி இது எல்லாமே you can write. And also what about the slope for a fixed end? Fixed end ஆ இருக்கும்போது no rotation possible because in the fixed end rotation is not at all possible. There is no freedom. It is having no freedom to rotate or to move horizontally, not vertically. Okay, so freedom for a fixed end or rotation at a fixed end is always 0. Okay, so இது வந்து hinge or roller ஆ இருந்தா the theta value will be there because it is allowed to rotate. So theta will be not equal to 0 when you are writing the equation. அங்க உங்களுக்கு அந்த theta A, theta B, whatever it is, that term of that slope will be there. Okay, deflection pathina 3 delta by L, and the delta stands for it is the deflection between the two. And this end irukku AB and the end la irukkireyo what is the level difference between them that gives the delta. Okay, so ungalku theta and delta is you are getting from based upon the type of question. Over question liyum enna support irukku adu paathu na theta value edukalam, and also what is the sinking level difference evlo irukku adu base panni I can write the delta value. And MF term, that is fixed end moments, you can write based upon the set of formulas, and that is also it is related with or it will change based upon the loading. Okay, loading on support ku etta mari fixed end moments maru. Okay, so let's see that these are the set of formulas. So நிறைய formulas இருக்கு based upon the loading. இப்போ first case பார்க்கலாம். All are assumed as fixed ends. அதனால தான் fixed end moments னு சொல்றோம். Okay, so fixed end momentsல when you are having a point load that too at the center, அப்படினா the formula is PL square by 8. So இங்க PL by 8 and PL by 8 both are term padi. Okay, when you are taking the magnitude it is PL by 8, but when you are taking the direction appadina edutha left hand moment is what is the direction? It is anti-clockwise. Right hand moment it is clockwise. You have to take the value of the sign as left side la irukra ella fixed end moments, so you have to consider it as negative, and right hand you have to take it as positive. Okay, so not in all cases the value, the magnitude will be same. Okay, so fixed end paakumbodhu anga point load, okay, when it is symmetrically loaded அந்த மாதிரி இருக்கும்போது both left and right end fixed end moments will be same in magnitude but opposite in direction. Okay, negative on the left hand side, positive on the right hand side, but only for the moment both left hand side and right hand side fixed end moments will be positive. Okay, only for the moment case that you will see. So idhula vandu nariya cases varudhu. Idhula vandu oru point load at the center, idhula vandu the eccentric loading not exactly at the center, point load exactly at the center la illa. Okay, A B rendume different ah irukumbodhu the fixed end formula will be P, the load is P B square A by L square, and here it is right hand side positive sign P A square B by L square. So A ங்கிறது left hand side la irukra distance, B ங்கிறது right hand side la irukra distance. Okay, so இந்த மாதிரி ஒவ்வொரு கேஸ்லயும் இந்த மாதிரி formulas are available, you can learn it. Okay, இன்ன நம்ம क्वेश्चनல எந்த மாதிரி லோடிங் இருக்கு, கண்டிப்பா end support will be all fixed, ஆனா எந்த மாதிரி டைப் ஆஃப் லோடிங் வருது, இப்போ காம்பினேஷன் ஆஃப் லோடிங் வருதுன்னு பார்த்துக்கணும். Suppose fixed end is coming and UDL is also coming, both are acting, then ரெண்டுத்துக்கு இருக்கிற terms you have to add. இப்போ point load என்ன பார்த்தோம், central point load PL by 8. So again you have a UDL, you have to add WL square by 12. அந்த மாதிரி ஒவ்வொரு term according to the type. So individual loading case la we have set of formulas for UDL, for UVL and for point load, eccentric load எல்லாத்துல இருக்கிற formula you have to learn. இது combination வந்தா individually you have to add. இப்போ left hand sideல இருக்கிறது எல்லாமே add பண்ணணும், இல்ல right hand sideல தேவை அப்படின்னா you have to add in the right hand side. That's it. Okay, then now these are the very important. இப்போ நிறைய formulas பார்த்தோம், அதுல most frequently asked is this. So central point load la irukkiradhu enna, eccentric load correct ah center la illa appadina left hand side la ella negative, right hand side la positive. Okay, this is UDL is asked and half UVL. Okay, and also what is the moment? So moment case la na sonna concentrated moment at a point irukku. Okay, a moment of 50 kilonewton meters acting exactly at the center. And the mari kodutha, what is the fixed end moment? So both are positive. See the sign, both are positive, and it is m by 4 and m by 4. And suppose idhe vandu eccentric ah irukku, okay, correct ah vandu center la illa, okay, and the mari vandu what is the formula there? So you have to go through all this, you have to learn. Okay, then when you are seeing what is the procedure, now ipo vandu slope deflection method vechi I am going to analyze. Okay, so analyze பண்ணிட்டு I am going to get the unknowns. அதுக்காக I have to write the slope deflection equation. So formation, the full method of slope deflection equation method is, first thing is you have to assume that all the ends are fixed. You have to assume appo the fixed moments vechi edukanum. Okay, then next is you have to write the xt equation, slope deflection equation. So equation nama paathom, or span ku rendu equation எழுதலாம், adla theta value delta value according to the question given நாம எழுதலாம். Fixed moments வந்து standard cases of loading which I can write. Okay, so finally you can write the slope deflection equation. adukaprom then you have to write equilibrium equation. Equilibrium equation na enna na sum of all the moments at a joint equal to 0. So suppose அது வந்து ஒரு continuous span ah இருக்கு. Okay, it is continuous beam or 3-4 spans are there, then at a joint the sum of all the moments, left pakku irukku right pakku irukku, when you add the sum of all the moments at a joint is equal to 0. It's not necessarily only 2 members are there, 3-4 எத்தனை members ah irundhalum at a joint edutha, okay, then the sum of all the moments equal to 0. So அந்த மாதிரி எடுத்து you will get an equation. So when you are writing an equation, the unknown can be found out, and the unknown then I am substituting it back to the ST equation. So ST equation is you are writing it for the moment. So you can finally get what is the moment value. Okay, moment value தெரிஞ்சது அப்படினா you can draw the bending moment diagram, you can get the slope the shear force diagram. So both you can do. Okay, so final analysis la enna enak requirement, momentum shear force main, so I will get that. Okay, so this is a complete procedure. We'll see some previous year questions, okay, based upon this. Okay, now this is the question, this is konjam theory, so you have to read, understand and see which are the statements correct. Okay, so first one, the slope deflection method is a stiffness method. Okay, stiffness. So stiffness nama paathom, slope deflection method is coming under displacement method illa deflection method. So it is stiffness method, then in which the joint displacements are found by applying the equilibrium conditions at each joint. So equilibrium condition at each joint na edukren, that means sigma moment at a joint equal to 0. So that's what they are telling. Okay, that's correct. Yes, according to the procedure you have to write the slope deflection equation and adukapra equilibrium equation போட்டுட்டு you have to find the unknown and substitute it back to the ST equation. இதுதான் procedure. Okay, so first இது வந்து A is correct. Okay, that is correct. Then the second one, the reason for this, okay, the displacement at a joint of a member are independent of the displacement of the member at the far end. So ஒரு எண்டில் நான் வந்து ஒரு டிஸ்பிளேஸ்மெண்ட் கொடுத்தா the far end it is independent. So நம்ம வந்து எந்த மாதிரி எடுத்தோம், terms தனித்தனியாக எடுத்தோம். I told you 4 terms are there. One is rotation at A alone, another is rotation B alone, then sinking of support and fixed end moment. So it is independent of the other end. தனித்தனியாக எடுக்கிறோம். So it is independent. So this is also correct. Now let's see the options. A and is true and R is false. No, both are actually correct only. but it is not the exact reason for A. So A oda reason kediyadu, individually it is correct. Okay, now so here you can write the option both A and R are correct, not the correct explanation of A. So that's the correct option. Clear? Now next one, the fixed beam of span L, or fixed beam irukku span L. Now then in that case it is subjected to a moment at the center span. So what I have to do, it is the fixed beam, this is a fixed beam, and at the center, exactly at the center I have a moment. So this is L by 2, L by 2, this is B and A. Okay, a span, it's a fixed beam. அதுக்கு சென்டர்லேயே எனக்கு ஒரு மொமெண்ட் இருக்குது. தென் வாட் இஸ் த ஃபிக்ஸ்ட் எண்ட் மொமெண்ட்? ஸோ இந்த டேப்லெட் காலத்தில் நம்ம பார்த்தோம், மொமெண்ட் வரும்போது ஃபார் லெஃப்ட் அண்ட் ஃபார் த ரைட் இட் இஸ் சேம் constant value. So that is m by 4. So this you have seen in the tabular column. So it is m by 4. Okay. So direct questions you can expect. What are the fixed end moments? So ஒரு case scenario கொடுத்துட்டு this is the type of loading. What is the fixed end moment? அந்த மாதிரி question வரலாம். Okay. So this is what you have seen. Both m by 4. Okay. Then the next one is the slope deflection equation of a member BC of a frame shown in the figure is given by. So either they are asking you to write the slope deflection equation for which member exactly? It is for the member BC. So BC member ku na eludano for this entire frame. So BC is coming here. This is BC and it is loaded with the UDL. So generally I am writing an equation அப்படினா MBC, I am writing for the MBC. So முன்னாடி பார்த்த the slope deflection equation மாதிரி I am writing. So it is 2EI by L, then it is twice of the first one, correct? The rotation of the first one. So twice of theta B, then theta C minus 3 delta by L plus fixed end moment. I have to write the fixed end moment. You can write directly MFBC, correct? So this is the slope deflection equation, how you have to write for the member BC. Now இதுக்கு அப்புறம் இருக்கிற theta B, theta C, delta la question பார்த்து நாம எழுதணும், கரெக்ட்டா? So theta B ங்கிறது rotation at B. Rotation at B எப்படி இருக்கும்? How I can write theta B? Theta B is not equal to 0 because எதனால அங்க rotate ஆகல? It's not a fixed end. What about theta C? It is also in between. So அங்கேயும் rotation நடக்கலாம். It's also not a fixed end. இதே வந்து A, ER இருந்தா it is a fixed end. D is a fixed end. So directly you can write 0. So theta B and theta C are not equal to 0. Correct. Then in the case la, what about delta? So BC, B க்கும் C க்கும் இருக்கிற level difference. Can you see any level difference between B and C here? Because it is a fixed end and nothing is mentioned in the question. ஒண்ணுமே சொல்லல. So then there is no sinking of support there. So directly you can write delta value is 0. So this delta I have to take it as 0. So this is 0. What about fixed end moments? What about this fixed end moment? MFBC. இது எந்த மாதிரி loading இது? This UDL. So UDL caseல fixed end moment formula is WL square by 12 and that too B to C. B is in the left hand side. So left hand side sign is negative. Correct? So I have to substitute this formula here. So here 2EI. EI is a constant. அவங்க EI பத்தி ஒண்ணுமே சொல்ல. So I can write 2EI. And what is the L? L is the length of BC. It is 8. So you can directly write 8. Now it is 2 times theta B. I don't know the value of theta B and theta C. So I am directly writing theta B, theta C and this term is 0. Now plus minus WL square by 8. Minus W ங்கிறது load 15. L ங்கிறது span 8. 8 square by 12. Okay. So I can cut the common terms. Yes. So here I can cut it 15, 12. So 5 and 4 and this also I can cut 2. So it is 5 into 16 or directly I can write 5 into 2, 10. So 8 into 10, 80. So it is minus 80. I am getting this entire term minus 80. So here it is, idum cancel pannalam. It is 4, Final answer will be 2ei by 2ei by will get cancelled. So finally ei by 4 into 2 theta b plus theta c, then minus 80. This is 80 coming. Okay, so which is the option here? MBC, it is ei by 4 twice of theta b plus theta c minus 80. So it is the first option. Correct? So in the manner equation எழுதணும், what are the details from the question? In the support கேத்த மாதிரி I will get delta and theta values and fixed in moment direct formula. Okay, now moving on to the next question. So A is the option. Now the next question similar to the previous one. இதில் என்ன slope deflection equation at the end 2. So instead of marking it the frame as ABCD, I am marking it as 1 2 3 4. Okay, so here end 2 of the member 1 2 for the frame shown in the figure. Okay, so 1 2 la இந்த 2 end க்கு எழுதணும். So it is m ல இருந்து start பண்ணோம். How we can write? M 2 1. The same way I can write. What is m 2 1? Now in the moment in the slope deflection equation I can write. So it is m, first I can write fixed end 2 1 illa 2ei by L also I can write. எப்படி வேணாலும் எழுதலாம். அந்த fixed end moment நான் வந்து கீழே எழுதுறேன் இல்லை directly first எழுதுறேன், எங்கே வேணாலும் எழுதலாம். ஓகே, ஸோ 2ei by L into it is for 2 to 1 because 2 end தான் உங்கள் கொஸ்டினில் கேட்டிருக்கு. ஓகே, end 2. So it is twice of theta 2 because theta for the end 2 plus theta 1 minus 3 delta by L. So this is the slope deflection equation. So idhila irundhu what from the support I can write theta 2 theta 1. What about theta 1? It is fixed end. So fixed end irundha I can directly put it as 0. Inga delta value varuma. What is the delta? 1 க்கும் 2 க்கும் இருக்கிற level difference. Since it is a column, இதில் level difference வரலாம் because it is having a horizontal force here. So அதனால delta not equal to 0. What about fixed end moment? Fixed end moment வந்து ஒரு loading caseல மட்டும்தான் வரும். ஆனால் இந்த loading இங்கே ஒன்றுமே இல்லை, no loading. So directly you can take fixed end moment also equal to 0. So finally you can write the equation as 2ei by L twice of theta 2. Theta 1 is not there, minus 3 delta by L. So this is the option. Correct? So which is the option coming here? 2 ei by L, 2 theta 2 and 3 delta by option C. Correct? So moving on to the next one. Here the magnitude of fixed end moment for a span if one of the support sinks by delta. So sinking of support case மட்டும் தான் கேட்குறாங்க. So what is that? நம்ம படித்தோம் நாலாவது டேர்ம் மட்டும் அந்த சிங்கிங் ஆஃப் சப்போர்ட் மட்டும்தான் கன்சிடர் பண்ணுறேன். ஸோ சிங்கிங் மட்டுமே இருந்தால் அங்கே பிஎன் சிங்க் பண்ணுற மாதிரி நான் கன்சிடர் பண்ணுறேன். ஸோ தி சைன் இஸ் நெகட்டிவ் அண்ட் த வேல்யூ இஸ் 6ei delta by L square. ஸோ கரெக்டாக அந்த 6ei delta by L square டைரெக்டாக அவங்க எடுத்துருக்கு வித்தவுட் எனி சைன். ஸோ வாட் இஸ் த மேக்னிடியூட் 6ei delta by L square. ஸோ ஆப்ஷன் D. Okay, so the option D is the answer. Correct? Okay. Thank you.